Hello and welcome to the Section 12.1 application walkthrough. In this in the first two problems here, you're just graphing the following quadratics and then stating the domain and range, just the domain. Make sure you get those done. Okay, I think you guys are more than equipped to do those. Those are the same types of problems that we saw in the notes, in the lecture, and the practice as well. So you guys are good to go on those, but let me know if you have any questions on them. For number 3, though, it's a little bit more difficult, all right, especially if you look at some of the numbers in there, shows you that it's quite a bit more difficult. So I'm not even going to try to pronounce that lady's name. I would guess it's Natalia, but Lisvakaya, I don't know. I tried. I said I wouldn't, but I did. Okay. Whoever that is holds the record for the woman's shot put. So that's a big metal ball, throwing it into the gravel pit. And how far you throw it, that's what you're looking at. The path of her record-breaking throw can be modeled by negative 0.01347x squared plus 0.9325x plus 5.5, where x is the horizontal distance in feet and y is the height in feet. So you're looking at x being horizontal, y being vertical. Okay. The initial height is represented by the 5.5. The height at which the shot, which is just again a 4-kilogram metal ball, was released. Okay. So that's like where her arm got extended to before she let go of it. That distance from where that shot was to the ground was 5.5 feet. That's all that part's saying. So what we're trying to find here is the maximum height of the shot. All right, so that's going to be the y-coordinate of the vertex. And then part B says, what is the distance of the throw to the nearest tenth of a foot? And don't go online and try to find it. I don't even know if it's still the current world record. I don't know. But yeah, go ahead and do the math. It's number one, it's just going to help you more. And number two, I think it's a little bit less time even. But you're looking at what is the x-coordinate when y equals 0. So we'll have to figure those parts out. But let's go ahead and look at the maximum height of the shot. So, all these graphs that we've had have had some sort of U shape to them. And this one would have a downwards U. And, so it's released at 5.5. Is that feet? Yeah. So 5.5 feet, and it goes, and then it hits the ground at x equals 0. Okay, we need to know, part B is looking for what is the y value there, but part A is looking for what is the maximum height, so that's the y value where it changes directions from going upwards to downwards. Okay, and to find that, we just need to find the y-coordinate of the vertex. So the x-coordinate, if you remember, is negative b over 2a. Well, this is going to be kind of complicated because those numbers are pretty ugly. So negative 0.9325 divided by 2 times negative 0.01347. Okay, great time to use a calculator. I wouldn't try to do it in my head, but I have 0.9325 divided by 0.01347. And that seems like a lot. Oh, I didn't multiply by 2. That's probably why. So 0.9325 divided by 2 times 0.01347. That's a little bit better. Still seems like she threw that thing way up in the air. 34.7 feet is what that would round to. Okay. So, that being said, that was ugly. Ugly numbers, but you can round once you get to your last step. I usually don't round in the intermediate steps because that throws your numbers off a little bit. So, probably the easiest thing to do, or I guess one way to solve this next part would be to graph it. And then the other way, remember we learned that whole solve by factoring thing, And not that it would be very good, but you do want y to equal 0. Okay, you want the height of the shot to be 0. So you could say that this all equals 0 and then figure out what you'd have to do to solve that. Again, that's fairly difficult. What I would expect that you do is to kind of use a guess and check method. Start picking values for x until you get closer and closer to 0. So I'm just going to write some notes here. Plug in x values that force y to get closer to 0. Okay, so plug in x values that force y to get closer to 0. Just meaning, you're probably going to look at some pretty big x values. Remember, this is a world record, at least at one point, distance that you're looking for. So just make sure you get your x's going bigger and bigger. If your y goes negative, okay, you've gone too far. All right, if that makes any sense, because the shot isn't going to go below ground level, right? It's gonna land on the ground, probably bounce up a little bit based on what kind of pit they're thrown into. But make sure you just stop when, like I said, if excuse me, if you get a y value that's negative, you've gone too far. So good luck on that. We'll talk about that problem in class if you need to. Other than that, good luck on the mastery challenge, and we'll see you later.